Deposition, so when sediments get put down. So the process by which sediments are released, settled, or dropped from an erosional system. So something moved them, so now they get put down somewhere. Okay, so factors that affect deposition usually is how fast the water or the source is moving. So it's how fast the wind is blowing, how fast the glacier is moving, all that kind of stuff too. So the slower it is, the more deposition that's going to happen. Slower water moves, it's not going to move as much. It's going to put those sediments down. So the characteristics of these sediments, I said it when we talked about erosion, now we're going to talk about it with deposition. It's very important to know the characteristics of these sediments, that the larger the particles, they're going to get dropped down faster. The rounder the particles, that means that the farther they have traveled because they've had more time to get banged around and to get weathered more. And the fact that their density, if they have a higher density, then they're going to drop down faster because they technically will weigh more. Okay, so these are different depositional happenings. And what happens is like this was a flood and all of the particles that were largest were laid down first, then the next size, and then smaller, then smallest. Then another flood or something happened, and then the different layers of these were laid down. And again, something like that happened. But you notice that the larger particles are on the bottom, the smaller ones will be on the top. Yes, there are some small particles kind of mixed in between with the large particles, but that's because those get stuck and where the water might be moving slower. But generally you see largest on the bottom, smallest on the top. Okay, so you also can show too that the rounder the particle, the faster it's going to fall, whereas the flatter the particle is, the slower it's going to fall. So if you were to drop something, a marble versus a penny, if they weighed the same, they were same density, same everything, you would notice that the rounder marble would actually fall faster than the penny would be. Okay? So gravity and deposition. So unsorted and unlayered sediments. Gravity and glaciers are unsorted and unlayered. Okay? Angular and unsorted. That's what glaciers and gravity have to do with. So it's a pile of sediments at the base of a cliff. Where streams and rivers are a little bit different. So is wind. That causes graded bedding, which is when everything was mixed out, it evens itself out. Rapidly forming layers where sediment size decreases from the bottom to the top. You can have vertical sorting and you can have horizontal sorting. We'll talk about those after. When stream enters a deep lake, you might need to add that to your notes if I didn't add it for you. Then you're going to draw a picture of what it looks like. So this is graded bedding. You have the smaller pieces on the bottom, larger pieces on the top. The only reason why this other layer is up here again is because I said that the water had moved faster at that time. There was probably a flood, and then all of these sediments got laid on top of the other sediments. Okay, so that was vertical sorting. Horizontal sorting occurs when the water gradually decreases, like when it enters a stream into an ocean, like at a delta. The larger, denser, more rounded sediments settle first, and then the farther out you go, it's going to be smaller sediments. So a lot of times this is when a river enters the ocean. So you can see here that the river's entering the ocean. Those larger boulders are first, then you have your pebbles, sand, silt, and clay, and usually dissolved particles are also known as colloids. Those are those stay suspended basically for a very long time. Now, what are particles how are particles deposited? Well, with wind and water, they're going to be sorted and rounded, so they're going to seem as though they're layered. Glaciers is a little different, but then we're going to talk about all the features that go along with glaciers. So one of the first features is a moraine. A moraine basically is when a glacier acts like a bulldozer. If you've ever been in a sandbox, like when you were a little kid, and you took a block and you put it on the sand and then you pushed the block in the sand starts to build up in the front of the block, just like a bulldozer would. That's exactly what happens with a glacier. A glacier comes down, it moves and moves and moves, and it's pushing all of this sediment, and it pushes a lot of sediment sometimes because they're so big. And what happens is it creates this large mound, and in Long Island's case, an island size, And it's found at the end, moraines are found at the end of a glacier, usually at the sides of a glacier or down at the very end of it. And it's all unsorted sediments and piles of sediments. So you can see here that the glacier must have traveled through this way, and the moraines, or no, it traveled this way because these are terminal moraines, these are the outsides. So when the glacier kind of came through, it pushed and gouged its way out through. Sometimes you also can see them that they came this way. In fact, this one did come this way because you can see the drumlins here, that it pushed down, and this is the terminal moraine, meaning it was the end of it, and then it kind of receded, and then it pushed down again, and then it receded. So this was a second moraine created. So this actually pushed down this way, pushed all of that sediment, created this big mound here. The glacier retreated, it came back again, and it left another moraine right here. Okay, so these are actually moraines going down through here, and this centerpiece right here is a moraine because there's glaciers that are traveling around these mountains, and it pushes the sediments off to the side, or it creates a trail of sediments through it too. Okay, this is that same picture, just taken many years ahead of time. So there's Long Island. Long Island is a moraine. The glacier had come down and pushed, and then it receded, and then whatever was left over, that's what was there. Okay, so this is the end of this glacier. There's actually a moraine of sediments down at the end here. Now, another feature with glaciers are going to be drumlins. Drumlins look like oval-shaped teardrops, basically, and they indicate the direction the glacier came from. The steeper slope, so the steep side of the slope, points to the direction that the glacier came from. So the steeper slope in this one is actually up over in this area. The gradual slope is over here, the teardrop piece, the point piece of it. That's where the glacier had gone this way. So that's the direction that the glacier had come from. So the ice moved this way, came from that way. So you have a series of these little hills and mounds. That's what the glacier left behind. These are called drumlins. Oh no, I didn't mean to do that. So there's another drumlin in real life. Another drumlin. Kind of looks like a fish coming up through the land, a giant fish. It's kind of cool. You can see that this is the steeper side, so the glacier came from that direction. Kettle lakes, these are another cool feature of glaciers. So what happens is that there are giant blocks of the glacier that get left behind. They got stuck in the ground, and over time, once it melted, the water no longer seeped into the ground, and the water just kind of kept refilling as a body of water, and it eventually made these things called kettle lakes. Round Lake in Ballston Spa is actually created from a glacier of leftover glacier water, and it makes Round Lake in Ballston Spa. They're pretty cool looking lakes. So that was actually gouged out, that area was gouged out by a glacier, and then the water filled in from it. Sometimes the ice block stuck there as well. Just like this, the ice got stuck, sediment came up and built around it, the ice melted, left this kettle hole, and it fills up with water from the water table usually. These are a whole bunch of different kettle lakes. Outwash plains. So these are formed from the running water. So running water is coming from the glacier. So glaciers are melting, and they sometimes have this running water coming out of it, and it carries sediment. So due to the fact that it's coming in running water, those sediments are going to be sorted and rounded usually, even though it's from a glacier. A lot of times they can create delta-like features. So the glacier is up here, and then you have this outwash plain that's kind of flowing through. Depending on the time of year and all that stuff, depends on how much water is coming out of it. Okay, outwash plains are down here, so you have the ice that was melting, the water runs through. These outwash plains are what are left behind. A lot of times it's sorted sediment that comes through because it came out of the glacier. So here's your melting glacier, and then you have all these little outwash plains coming out of it. Here's another outwash plain. This one's a really cool picture. This is in the summertime too, because there's lots of green things. It's not usually green when it's winter. So how are these particles deposited? Anything to do with glaciers and gravity are going to be angular and unsorted. I cannot get that to you enough, okay? So they're unsorted and angular sediments when they have to do with glaciers and gravity. Okay, this is from gravity breaking things. All this stuff's unsorted, it's angular, nothing's rounded. So glaciers, they move fastest in the middle. They move downhill. Glaciers have U-shaped valleys because rivers have V-shaped valleys. It drags boulders, leaving parallel grooves, polished bedrock. The Finger Lakes in New York State are actually caused by glaciers. They actually flow towards the north because of how the glaciers change the landscape and whatnot. And Long Island is a moraine. The polished bedrock is because the glaciers had dragged over it and actually caused the bedrock to be exposed. And if there were not rocks in the part of glacier to create the gouges, it polished the rock. It kind of smoothed it out a little bit. Dragging boulders, that's what those parallel grooves are for. We talked about them with plate tectonics. The big glacier has rocks stuck in the bottom of it, and when it moves, it drags those rocks on other rock, so you can actually see the grooves from it. Wind and deposition. So sand dunes are actual gentle slopes facing into the wind. You can see sand dunes when you go to the beach sometimes. You can see sand dunes if you've ever gone to the deserts or if you've ever seen pictures of the desert. The steeper slope is on the side the wind is blowing towards. So actually the wind is blowing towards this direction, and it kind of builds up at the top, and then some pieces fall over the edge. So how are particles deposited? So with wind, they're sorted and they're rounded. That's the most important part. Wind, water, round and layered. Wind, water, round and layered. So with the ocean, another feature of deposition are sandbars. These are created by longshore currents. Longshore currents are the currents that follow along the shore. And sandbars can be created farther out from the shore. It kind of separates water from land. You also have barrier islands that do the same thing. They run parallel to the shoreline. Fire Island in Atlantic City, Fire Island in New York, Atlantic City in New Jersey. Those are all different types of barrier islands. We do have some man-made features to prevent those things from eroding too much of the sand and sediment away. So they have these things called groins. There are these big walls that kind of jut out into the water, and it prevents a lot of the sand sediment to keep moving down the beach, so it doesn't wash the beaches away completely. So you can actually see these big metal pieces, they jut kind of out in the water, and it prevents a lot of the sand from moving down the beach and ruining the beach. Sometimes they'll come back in here and they will bulldoze a lot of the sand and they'll remove it at different parts of the beach. But those are called groins. This is another groin. Keeps that from the sand moving down the beach. These are more groins. These are in Washington State. Sometimes these groins are actually property barriers too. So that's a case. Jetties. Jetties are walls of concrete that go out into a harbor entrance, and that prevents the sediment that comes out from these harbors from going directly onto the beaches and either ruining the beaches or making them too big, or all these different factors. It also allows for the sediment to go farther out into the ocean so that the sand doesn't build too much up in the waterway, that they don't have to clean it out or dredge it too much. So this is another jetty. And then we have deltas. You need to know what deltas are. They're the positive sediments at the mouth or the end of the river or stream where it flows into a still body of water. So here you have a delta, and it kind of looks like a tree, that the water is then flowing slowly, so everything kind of gets deposited at random places until it goes out into the ocean. Just because the water's moving so slow, it can't move a lot of sediments quickly. So here's another delta. The water's flowing in this way, so it creates lots of little waterways. There's little deltas in all over Florida too. This is a computer-generated delta. This still gives you the idea. So how are particles deposited? They're sorted sediments and they're rounded. When they have to do with wind and water, they're rounded and layered. Wind, water, round, and layered. Gravity and glaciers are always angular and unsorted. You need to know those for your test. So just a couple extra things. Potential energy is energy that is stored. So it's always going to be at the highest position. So potential energy is going to be at A, and then potential energy is going to be back down at D. A has the highest potential energy because it potentially could go farther than D could. Kinetic energy is going to be your energy in motion. So any sediments that are at B and C would be in motion. B would have a higher motion because it has a greater slope. C, it wouldn't have as great as kinetic energy because it has less of a slope. So you need to make sure you write all those in. That's exactly what I just talked to you about. So make sure you pause the video to write all this stuff in. And then we've talked about oxbow lakes before. That has to do with deposition. The fastest water is going to be moving right down the center until you get to the curve, and then the outside of the water is going to be faster. Outside of the curve is going to be faster until it gets to the ocean. Deposition is going to happen on the insides of the curves. We talked about this before too. Remember that the water moving the fastest around the outside, more erosion on the outside, depositions on the inside because the water is moving the slowest. Fastest water always moves right down the middle on a straightaway. Okay, make sure you write those in. Those are all the things that we talked about before too. And this is just reinforcement of horizontal sorting. When a river enters a larger body of water, such as the ocean, you have your large sediments over here at the very beginning of where the water met the ocean, and the farther you go out, the particles get smaller. This is horizontal sorting. We talked about this chart. This is in your reference tables. That's also the size of particles, and this one actually shows you the vertical bedding, or the vertical sorting, where like a stream enters a pond or something like that, that you have the largest pieces on the bottom, smallest pieces are on the top. And then what happens is that sometimes there's flooding or different times of the year when the water moves faster. This is why we can have different layers of larger rocks on top of smaller rocks. At some point the water moves fast enough to move larger particles into that body of water. Okay, and then we'll talk about this at a different time.